those sitting in the back, can you hear me? You can hear me, right? Okay, good. Thank you. Because the mic is not working properly today, I think. So today we are going to have a quick tutorial to talk about socket programming. And as you know, our lab project number 5 and project number 6 all about socket programming, right? Because project number 5, most of you should have already done that, right? Have you? No, not yet. You still got another week to work on that. Project number 5 is for you to build a TCP client, right? And maybe I should use this one instead. And project number 6, on the other hand, is for building a TCP server, right? So as you can see, for you to build a client and a server, you definitely need to know how to work with socket. Socket is a very important programming interface offered by most of the operating systems, including Unix in particular. And our job today is to have a quick discussion and introduction to socket programming. The first thing I want to ask is, anybody knows what a socket means? It's too simple, the question? Basically, you know that socket means a communicating endpoint, a communicating endpoint. But this endpoint is at the transport layer. So the key idea here is because it is a transport layer endpoint, so it actually refers to communicating application. It doesn't refer to just a communicating host. It refers to a communicating application. So therefore, in order to uniquely identify a talking application, you have to provide two pieces of information. Yesterday, we also mentioned that. The first piece of information is the IP address. The second piece of information is the port number. Right? So using the IP address together with the port number, you can define the address of the socket. Right? So whenever we talk about the address of the socket, we are talking about a combination of IP address and the port number. So therefore, the port number plays a quite important role for defining the address of the socket. So that's why we want to have a quick look at the port number. Now you can see that if you are communicating over the internet, then the port number is always described by 16 bits. Right? If you're communicating with a different network, then the port number doesn't have to be always 16 bits. But for the internet, it is always 16 bits, right? So with 16 bits, we can represent a wide range of port numbers, varying from 0, which is the smallest port number, to a very big one, which is 65,535. We have a very big range of port numbers. And among this range of port numbers, we can chop them into 3 separate parts. The first part is what we call the reserved port number. Right? This area of port number is reserved. It can only be used by some specific services. You cannot use them for any other purposes. They are completely reserved for specific services. The second range of port numbers from 1024 to 5000 is what we call ephemeral port numbers. Ephemeral port numbers can be used by a client to talk to a server. So whenever a client wants to talk to a server, the client needs to use a port number as well. And that port number can come from this ephemeral range. Now, having said that, we have to also acknowledge that some of the port numbers in the ephemeral range have also been registered for providing some specific services. And you can check. IANA is the authority for all the port number allocation. You can see that some port number in the ephemeral range have also been registered for use by specific services. However, if in an internet host, you are not offering a specific service that uses the ephemeral port number, then that port number can be used for communicating with another server. So that's the idea. Besides that range, there is another big range of port numbers, about 5,000. And that range is what we call the general range port numbers. And this range of port numbers can be either used for servers as well as for clients. However, you can see that if you offer a service by using a general purpose port number, then that service perhaps is only accessible within a local region. It cannot be accessed anywhere from the internet if you use a port number in the general range for your service. Okay? However, you can use that port number for communicating with a server. That's no problem. But if you offer a service, then the scope of your service can be affected. Because we know that a proxy server or a firewall can be configured to filter out any incoming request for a port number in this general range, right? So you can see that in general, based on the port number that your application uses, highly likely you can tell what kind of service your application offers. So here we have some examples, like whenever you have an application listening to port number 21, you know that this application highly likely is offering an FTP service. This application is used for sharing local files with internet users. On the other hand, if you know that the port number the application is listening to is port number 80, then you know that highly likely your application is offering the HTTP service. And we know that any application offering the HTTP service highly likely is a HTTP server or is a web server, right? So this port number is basically used by web servers, right? So you can see that it is quite important for you to remember the use of some port numbers like 21, 80, and another port number you have to remember is 25. Anybody knows what service is using port number 25? Not really? Okay, so it is actually the SMTP server. Anybody knows what is SMTP server? No? Because we haven't discussed it yet in the lecture, but you can see that SMTP is used for mail transferring over the internet. So application listening to port number 25 is usually a mail server. And so all you need is to remember these three port numbers: port number 21, port number 80, and port number 25. They can appear in the final examination. So port number, because they are playing a very important role for us to know which service are being offered by an application. Now, besides the port number, we know that using socket, we are able to access communication service offered by an operating system, offered by an internet host. And in terms of the communication service offered, they are quite varied, actually. Using the socket interface, you can access many different protocols. But the most important protocols that we want to access through socket is just the two protocols. One is UDP, the other is TCP. Although we know that we can also use socket to access other protocols, which we'll discuss briefly later. Now, the UDP protocol has already been introduced yesterday, right? We know that UDP is basically a connection lease, and it is also a message-oriented protocol. Right? Being a connection lease protocol means UDP does not provide reliable communication service. So we cannot be sure that communication is error-free, in order, and also there is no data loss. We cannot be sure of that at all. UDP does not provide any communication reliability. Having said that, UDP is also very flexible and efficient. So in some situations, we should consider using UDP. For example, if you wanted to send a lot of information around, you can consider using UDP because there is no rate limitation, no transmission rate limitation. Now, besides UDP, TCP is another very, very important transport layer communication service we can access through socket, right, which is also our main focus for the lab projects. Now, for TCP, it is connection-oriented, and it is also byte-oriented, right? So it is quite different from UDP. Being a connection-oriented protocol, TCP offers us communication reliability. So you can be sure that if you send information around using TCP, the information will reach the receiver eventually and successfully. And there is no change of communication order. The first byte you send will be always the first byte you receive. And TCP also provides flow control and congestion control, as we mentioned before. And those control mechanisms could help us to use the communication resources better. And we will see why they can help us to better use the communication resources. But you can see that we have two different, very, very different transport layer service that both of the two services can be accessed through the socket programming interface. Now, the next thing we want to talk a little bit about is how to handle addresses. Now, whenever you use sockets for communication, you need to deal with address-related information. Address-related information. And here we have some examples of the functions that we need to work with addresses. These three functions particularly require us to provide address to the operating system. The address we are talking about here is the socket address. Remember, it's the socket address, which means it is not the IP address alone. It is a combination of IP address and port number. That becomes the socket address. So we need to provide socket address for some important functions, like the bind function, which is used to bind a socket to a specific socket address. At the time when you create a socket, the socket is clean. It doesn't have any address. Now, before you can use the socket to accept incoming connection requests, you have to bind that socket to a specific address. And this is achieved by using the bind function. And whenever you use the bind function, as you can see, you have to pass a socket address to the operating system. Similarly, you can see for the connect function, this function is used for the client to connect to a server to establish a TCP connection. Now, in order to connect to the server, of course, you have to provide a socket address to the operating system. But this time, the address you provide is the server's socket address. It is not your own socket address. It is a server socket address that you have to provide. But you can see that there are many functions in the socket programming interface which requires you to pass a socket address to the operating system. Besides those functions, there are also functions that enables you to get a socket address from the operating system, like the accept function. The accept function is used for accepting an incoming connection request at the TCP server side. And whenever we have accepted an incoming connection request, we can establish a TCP connection with a client. At the time when you set up a TCP connection, obviously you want to know what is the location of the client, what is the address of the client. So using this accept function, we can also get the client's socket address at the server side. So this function gives you the address from the operating system. Another example is this receive from function. This receive from function is used by the UDP protocol. So as a UDP server, for example, I wanted to receive a datagram from the UDP sender, UDP client. In this case, I can use the receive from function. And whenever I receive the datagram, this function will return. And as a result, I can find out who sent the datagram to me, right? So therefore, this function can also pass a socket address from the operating system to user. So you can see that in the socket programming interface, there are many functions that require us to work with addresses. Some functions require us to pass an address to the operating system. Some functions enable the operating system to pass an address to us. So dealing with addresses are quite important for socket programming. So that's why the next thing we wanted to talk about is what data structure we should use to deal with addresses. Sorry?
For the reserved services, the port numbers, the reserved ones, they're used like both for the server and the client, they are the same?
They are used by the servers. The servers are using those reserved port numbers to listen to incoming connection requests or incoming service requests. They are not used by the clients. The clients have to use a ephemeral port number to talk to server. Okay. But you can see that in order to access a server, you need to know its location. So therefore, its port number is more important than the client-side port number. That's why we have this reserved region so that we are sure in practice which port number the server is using. Okay? So next thing we are talking about is what data structures we should deal with to handle addresses, right? The first data structure is called internet address. And this is the data structure for us to specify the address of an internet host, right? You can see that this data structure is very simple. It only includes a single member, and this single member basically is a 32-bit integer. Using this integer, we can specify a 32-bit IPv4 address for a particular communicating host. And based on this data structure, there is another data structure that we needed to deal with. And that is what we call the socket address. Now you can see that the socket address structure has three different members. The first member is the address family. We needed to specify the address family because socket can actually support many different protocols. And different protocols can use different address families. And for us, we are accessing UDP and TCP only. So the address family we are using is the Internet address family. That means that for the first member of the socket address data structure, the default value for this member is Internet address family. So you should use this one to specify the first member of the socket address in your program. We should use the Internet address family. And this is a constant default, but defined for you, right? So you don't need to redefine it. The next member of the socket address is the port number, and it is basically a short integer containing just 16 bits. If we are working with the Internet address family, right? If you are working with different address family, then the port number may not be 16 bits, right? And the third member is, of course, the Internet address of the communicating host. So we can now use the socket address data structure to specify the port number and also to specify the IP address. Together, we can define the address of a socket. One interesting thing about these two data structures is the port number you provide here and the Internet address you provide here, they must follow the network byte order. Now remember, they have to follow the network byte order. Now, we have this byte order issue because, you know, the address and the port number, they cannot be represented by a single byte, right? They cannot be represented by a single byte. So therefore, we needed to know which byte contains the most significant bits of an address and which byte contains the least significant bits of an address. Right? So if we are following the network byte order, that basically means we are following the big Indian scheme. Anybody still remember what is a big Indian scheme? Yeah? So the lowest address contains the most significant bits, right? So in another word, the first byte of your Internet address should contain the most significant bits of that address. And the last byte of your Internet address should contain the least significant bits of your address. So this is also the same thing for the port number. We have 2 bytes for the port number, right? The first byte should contain the most significant bits of the port number. That is the network byte order. Now we know that although we have to follow the network byte order, but in a real computer system like this, right, it may not follow the network byte order. If you are using particularly the x86 instruction set, then we know that we are actually following the little Indian scheme. So the first byte is actually the least significant bits for your port number and for your network address. So therefore, in order to use these two data structures, very often you have to use some function, facilitating functions. The first two facilitating functions you see here enables us to convert an address which is originally following the host byte order to an address that follows the network byte order. So this is the first function. You can see that you provide a 32-bit address which follows the host byte order, and this function will return you another 32-bit address that follows the network byte order. So when you set the address here, you have to use this function to convert your host byte order address to a network byte order address. So this is also the same thing for the second function, which can be used for port numbers. We can use this function to convert a port number originally following the host byte order to a port number that follows the network byte order. So these two functions are very, very important when you set these two data structures. Okay, so of course, besides these two functions, sometimes you might want to know what is the IP address of another host returned by the operating system. If this is the case, you have to use the next two functions, which converts a network address to a host address. Right? So that's the functions. They provide the other round of conversion, basically. Okay? So this is about the addresses and the data structures that we can work with addresses. The next thing we wanted to talk about is what are the functions that we can follow in order to support TCP communication. In order to conduct the TCP communication, we have to distinguish the two communicating partners so that one becomes the client, another becomes the server. This distinction is based on who should take the first step to set up a TCP connection. The TCP client will always be the application that will set up the TCP connection actively. So it will take the first step towards setting up a TCP connection. If that is the case, we call it the client. On the other hand, the server will never actively set up a TCP connection with anyone. Instead, the server will only passively listen to incoming connection requests. So this is the way for us to distinguish who should be the client, who should be the server. Right? So you can see that depending on whether you are a client or a server, the functions that you use can be quite different. So especially for server, we have quite a few functions to call one by one in order to set up a server properly. Now let's have a quick look of those functions. The first function that you need to use both at the server side as well as the client side is the socket function. Using this socket function, we can create a new socket instance inside the operating system kernel. So this socket data structure is maintained by the operating system, not by you. Right? Instead, the operating system kernel will give you a descriptor, and you can use that descriptor to refer to the socket. So this function, if it is successful, it will give you a descriptor of a socket that you can access. So once you have created a socket, at the server side, the next function you need to call is the bind function, so that we can bind this socket to a specific socket address. So that's why after this function, the socket has an address. Before this function, the socket doesn't have any address. So after you have bind the socket to a specific socket address, the next function you should call at the server side is the listen function. The listen function is not to listen to any incoming connection request. This listen function is simply used to put the socket into the listening mode. So before this function, the socket is not listening. After this function, the socket is eligible to listen, but it hasn't started to listen yet. We just put the socket in the listening mode. After this listen function, the next function is the accept function, as I just mentioned. The accept function is actually a blocking function. So when you call this function, the server-side program will be blocked because we are now waiting for incoming connection request. If there is an incoming connection request, we can set up a connection with the client, and then this accept function will return. Otherwise, the accept function will block the server. So if the incoming connection request is accepted, the accept function will also return you a new descriptor that you can refer to a new socket. So you can see that at the server side, I'm not working with just a single socket. I'm actually working with two sockets. The first socket is created here. The second socket is created by the accept function. The socket created by the accept function is used for communication with the client. It is used for communication with the client. The socket created by the socket function, on the other hand, is used for simply listening to connection requests. It will not be used for any other purposes, just to listen to incoming connection requests. Okay? So that's the difference. So after this accept function, we have established a connection with the client. So the next step is to use the receive function and the send function to exchange information with the client. And so for the client side, you can see similar things is happening. First of all, we need to create a socket, and after that, I need to use the connect function to try to connect to the server. So to call the connect function, of course, you have to provide the address of the server, and the address of the server. If this connection is successful, then again, you can use the send function and the receive function to talk to the server. And after that, once the information exchange is finished, the last step is to use the close function to close a socket. You can see that the close function needs to be called both at the client side as well as the server side, which means we have to close both sockets in order to terminate a TCP connection completely. You cannot just terminate the client end, but without terminating the server end. You have to terminate both ends in order to terminate a TCP communication or connection. For the close function at the client side, I'm closing the socket created by the socket function. On the other hand, at the server side, when I'm calling the close function, I'm actually closing the socket created by the accept function. I never close the socket created by the socket function at the server side. You only need to close the socket created by the accept function, right? Because you still want the socket created here to continue to listen to incoming connection requests. Yeah.
This might not be for this course, but how do you stop a malicious client trying to access the server?
How to stop a malicious client to try to access a server. What do you mean? Are you talking about DDoS attack or something?
Just any kind of client who's trying to, because you obviously don't want to let anyone connect to a server, or else you want to just start sending anything they want.
Yes, you can set up some kind of restrictions as to who can talk to you, but that is a system level configuration. It is not through the socket interface. Okay. But you can configure at the system level inside your operating system, which will encounter requests you wanted to listen to. Yeah. All right. So this is about the general functions you need. Let's take a closer look at each of the functions one by one. The first function is the sockets function. It requires 3 arguments. Right? The first argument is the address family, and of course for us we use AF internet. AF internet. This is the IPv4 address family that we are using. Right? The next argument is the type of the socket. Now you can see here we have 3 different types of sockets. The first is string type, which means byte-oriented communication. If the address family is the internet address family, and if the socket type is string socket, then you are actually using TCP for communication by default. The second type is datagram type socket, which means message-oriented communication. Again, if the address family is the internet address family, and if the type for the socket is a datagram socket, then by default you are using UDP for communication. So you can see you don't need to specify which protocol you use. If the internet address family is the internet address family, then by default, if it is byte-oriented, then it is TCP. If it is message-oriented, then it is UDP. Besides these 2 types, we have a third type called the raw type. The raw type is used for you to access network layer communication service. So if you want to directly access the IP protocol for communication, then you can use the raw type. Otherwise, if you just wanted to access transport layer communication service, then you should use either string or datagram type socket. So the last argument for the socket function is the protocol argument. The protocol argument is for us to specify which protocol we use. If the type is string or datagram, then the protocol can be simply set to 0, which means by default. In another word, if it is a string socket, we use TCP. If it is a datagram socket, we use UDP. By default, we use the default protocol. We set the protocol argument to 0. On the other hand, if you are using the raw type socket, then you have to specify which protocol you use. For example, if you wanted to access IPv4 protocol, then the protocol argument should be set to 4, because 4 stands for IPv4 protocol. So again, it's very similar to any other system calls. The socket function is a system call. So if it is successful, it will give you an integer, which is a descriptor for a newly created socket. On the other hand, if it is not successful, then it will return you -1. So you can check. If it gives you -1, then it means that, oh, this function is failed. And you need to find out why this is the case. So the next function that we need to use at the server side is the band function. And you can see again, several arguments should be provided. The first argument is the descriptor of the socket you have just created by using the socket function. Right? The socket function gives you a descriptor. Now it becomes the first argument to the band function. The next 2 arguments is used to specify the server-side socket address. So you need to therefore provide a pointer to a data structure that contains the server-side socket address. And also, you need to specify the total length of the socket address. The third argument is the total length of the socket address. Now we need to specify the total length because the socket address can vary depending on which address family you are working with. So that's why we have 3 arguments here. Again, if this function is successful, it will return you 0. On the other hand, if it is not successful, it will return you -1. As a common convention, whenever a system call returns you -1, you can check the possible cause of this error by checking a general variable or global variable called error number. Most of you might have already known that. Once a function returns you -1, you can check the error number variable to find out what is the cause of a system call failure. So this is the bind function. After the bind function, the next function is the listen function, right? The listen function is to specify how should a server socket listen to incoming connection request. Two arguments here. The first argument is the descriptor of the socket, which you use for listening to incoming connection request. This is easy. The second argument is what we call a backlog. The backlog is actually used to specify what is the total size of the incoming connection queue. So we know that sometimes if the server is very busy, it cannot process an incoming connection request. It will put that connection request into a waiting list, into a queue. And therefore, we need to know how big that queue is. So the backlog argument is used to specify how big that queue should be. So how many connection requests can be pending at the server side, in another word. The typical setting is to set it to 5. And in practice, you should never set it to up to 15 or above 15. Right? So for us, we simply set it to 5. It is good enough for most of the cases. So after this function, the server socket at the server side is now in the listening mode, and the next function we need to call, yeah. Because most of the time in practice, if you set it to about 15, it is good enough for processing all the incoming connection requests. Yeah. So I mean, this is based on practical experience. Yeah. The next function after the listen function is the accept function. This function, as I just mentioned, is blocking. Right? So this function accepts 3 arguments. The first argument is the descriptor of the server socket as before. The next 2 arguments, which is the socket, a pointer to a socket address data structure, as well as a pointer to an integer that contains the size of the socket address. These 2 arguments are used for retrieving the socket address of a client. So this is used for retrieving the socket address of a client. And in practice, very often you don't need to know the socket address of a client. If this is the case, you can simply put them to be 0. And so for the second argument, you can set it to 0. For the third argument, you can also set it to 0. This is what we do in our lab projects, because I don't care about the socket address of the client. And again, if this function is successful and whenever it returns, it will return you a new descriptor, and that new descriptor refers to a newly created socket at the server side. And that socket is used for communication with a specific client. So the socket you created previously will always be used for listening to incoming connection requests, as we know. Right? So communication with the client will use the socket returned directly from this accept function. Next function that we need to talk about under the server side is the close function. So after communicating with a client, we have to close the socket. And this time, to close the socket, you use the close function, and it only accepts a single argument, which is the descriptor of the socket that you wanted to close. This function is very simple, but there is a tricky part of this function. That is, this function is not a blocking function, which means that the close function will immediately return whenever you call this function. When this function returns, the socket may not have been actually closed by the operating system. Closing a socket is actually done in the background by the operating system. Anybody can let me know why we wanted to close a socket in the background? Anybody knows? Yeah? If there are some pending information to send, right? Yeah, that's what you mean, right? Yeah. So one important, as he said, is because communication can be quite slow. So sometimes when you wanted to close a socket, there might be still some pending information in the backup that you haven't sent to the other communicating partner. So therefore, the operating system will try to flash the backup for you before it closes the socket. Right? So that's why everything is actually done in the background. Having said that, the operating system actually has no guarantee that it will flash the buffer always first for you. Sometimes the operating system might be a little bit busy, so it decides to directly close the socket without flashing the buffer. So that means that sometimes some information might get lost. You have never reached the other communicating partner because the close function basically is non-blocking. So therefore, if you wanted to have reliable communication, if you want everything to be eventually sent to the other communicating partner, then you have to use a special option for your socket called the sole linker. So when you use this option, then the close function becomes a blocking function. So this function will block you until the buffer is flushed, until the socket is eventually closed by the operating system. To set this option, you can use the set socket option function, which we will not discuss, because in most of the cases, it is not that dangerous. The information you send to the socket will reach the other end. Yeah. So we see that there are several functions that we need to use at the server side. How about the client side? Again, at the client side, there are also some functions that we need to use. The most important function is the connect function. Right? We use this function to establish a connection with the server. So this function, connect function, should be called by a TCP client. So let's have a look at this connect function. The connect function accepts 3 arguments, right? The first argument is a descriptor of a socket that you have just created at the client side, right? So this is the descriptor of the socket for the client, okay? And the next 2 arguments is a pointer to a socket address data structure and also the length of the socket address data structure. These 2 arguments, the second and the third arguments, they are used to specify server's socket address. Now we need to know where is the server, so we need to tell the connect function the socket address of the server. So the second argument and the third argument gives us the address of the server. Notice that at the client side, we never use the bind function to give an address to the client side socket in the first place. Right? So after creating a socket, I can immediately establish a connection with the server. We never bind the client side socket with any specific address. This is because the operating system is very smart. Whenever you wanted to try to establish a connection with the server, the operating system will try to pick up and then use the port number and use it as the client-side socket address. So it is done automatically. That's why at the client side, you don't need to bind your socket to any specific address. After creating the socket, you can immediately try to establish a connection with the server. Okay, and again, if this function returns 0, we know, oh, a connection has been successfully established. Otherwise, if it returns -1, you should find out why the connection cannot be established properly. So anyway, in most of the cases, connection can be established successfully. And if this is the case, the next step is to try to send some information around between server and the client. Right? So in order to do that, you can use the receive function to receive information. You can use the send function to send information. Of course, we are not recommending you to use these 2 functions because we have another 2 simpler functions to use, which is the read function and the write function. Read function is used for receiving, write function is used for sending. So we recommend to use the read function and the write function instead because they look simpler than the receive and send function. The main difference between the receive and send function and the read and write function is for the receive and send function, you can specify a flag to specify what kind of transmission behavior you want. And they are too advanced for us. We don't care about how it is transmitted. As long as it can reach the other end, that's fine for us. So that's why we use the read and write function. So up to now, we have finished the discussion of all the functions in relation to TCP programming. Do you have any problem? Not really, right? It sounds very, very straightforward. So I hope you can finish your lab project in just a few minutes, maybe hours, right? So it should be quite straightforward, I hope. Now, yeah, another part we wanted to discuss quickly is how to use sockets for UDP communication. Although we don't need to do it in our lab projects, but it's interesting to find out how to use socket for UDP communication. Here we have a datagram that demonstrates what are the functions we need for UDP communication. Again, we have to distinguish a server from a client. And here our idea is the process who is listening to incoming datagram is the server. And the process who will send the first datagram is the client. This is our idea. So you can see that if you are working with a server, if you wanted to listen to incoming datagrams, you have to bind the socket with a specific address. Otherwise, no datagram can reach you. That's why at the server side, you have to use the bind function, which is very similar to the TCP case. You have to bind a UDP socket with a specific address at the server side. And at the client side, on the other hand, we don't need to bind the socket to any address, because the port number can be automatically assigned by the operating system. So you can see that because UDP communication is more straightforward than TCP, so the overall functions we need to call is also much simpler. You can see that we don't need to use the accept function, we don't need to use the connect function, basically. So after you have created the socket, you can use it directly for data transmission. And at the client side, if you want to send any information to the server, you use the send to function. When you use the send to function, you have to tell the operating system what is the socket address of the server. Anytime you use the send to function, you have to specify the socket address of the server. Even you are talking to the same server, every time you have to specify the socket address. And besides the send to function, you can also use the receive function, receive from function to get a datagram from the other end, right? So at any time, if you use the receive from function, you can also get the socket address of the sender, provided that the sender is willing to give its socket address to you, right? And finally, at the client side, you have to call the close function to close the socket so that we can release all the resources. But you can see that at the server side, we don't need to call the close function because we don't have any TCP connection here. You don't need to close both ends. Only at the client side, we call the close function because we wanted to release the related resources. The server, on the other hand, can keep on listening to any other datagrams arriving in the future. Okay, so here we have some, function definitions for the receive from function and the send to function. They're very similar to the receive function and send function. But you can see that the main difference here is that you have to provide an address. In the receive from function, this address you provide here is used for receiving the client address. In the send to function, the address you provide here is used to specify the socket's address of the server, the socket address of the server. So these two functions are actually quite straightforward to use, I hope. And one more thing I wanted to highlight here is that for UDP communication, you see here, although I said that we don't need to establish a connection with the server, sometimes the client can also call the connect function before it sends information around. So if the client calls the connect function first, then the UDP becomes a connected UDP. What do we mean by a connected UDP? A connected UDP doesn't mean that we have a connection between the server and the client. A connected UDP simply means that the client knows who is the server. Right? So the connect function, therefore, is used only by the client to specify who is the server. Yeah.
So let's say that the client is asking for like a request some data, and then the server keeps sending it data. If the client calls close, the server doesn't know, right? So it just keeps sending the data.
Yeah. Okay. And you can keep on rejecting.
Okay.
Yeah, UDP is very flexible. Which means no control at all, right? Yeah. So just now I mentioned about connected UDP, which means that if you at the client side you call the connect function, then the UDP becomes a connected UDP, which means that the operating system at the client side knows who is the server. Therefore, after you have set up a connected UDP, instead of using receive from and send to function, you can use the receive function and the send to and the send function to communicate with the server. So a connected UDP sometimes is easier to work with because every time you send information, you don't have to specify who is the server anymore, since you have already told the operating system who is the server. That's what we call the connected UDP. Another interesting thing I want to talk a little bit about is how to build concurrent servers. As you know, the TCP server has to be concurrent. While the server is working with a client, the server should still keep on listening to new incoming connection requests. This is what we require in the next lab project. We want the server to be concurrent. There are many different ways to build a concurrent server, and the approach that we will follow in this lab project is to use the fork system call. As I highlighted here. Use the fork system call. By using the fork system call, I can create a child process from a parent process. So I'm using two processes in the Unix system. The child process is used to communicate with a specific client, and the parent process, on the other hand, will keep on listening to new incoming connection requests. This is our idea. At any time, if you wanted to create a child process inside a parent process, you make the fork system call. You call the fork function. The fork function will be called once, but it will return twice. One in the parent process, one in the child process. Depending on what value it returns, we know whether we are in the parent process or whether we are in the child process. If the fork function returns you 0, we know we are in the child process. So therefore, we have to communicate with a specific client. On the other hand, if the fork function returns you a non-zero integer, basically that is the process ID of the child process, then we know we are in the parent process. If we are in the parent process, then we shall continue to listen to any new incoming connection requests. So by using the fork system call, we can produce a child process at any time if we wanted to talk to a specific client. Right? So in this way, we can build a concurrent server. So this part is more challenging, I think. The most challenging part for the next lab project. Give it a try. Okay, so that's the end for today. Thank you.